Today we are going to learn about algebraic expressions, the commutative and associative properties. Let's just get into it. So as a reminder, you guys can use the pause, rewind, fast forward, pause, rewind, fast forward button while you're listening through this lecture. You're supposed to be taking notes in your classwork while you do this, and yeah, take your time. This is not a race. So exercise 1. Susie draws the following picture to represent the sum 3 plus 4. What does that mean? Ben looks at this picture. Well, first we see Susie. I have 3 plus 4. Well, Ben looks at this picture from the opposite side of the table and reads, you drew 4 plus 3. So Ben is hanging out over here, looking at it, and he sees 4 plus 3. Susie's hanging out. Susie's going to be purple. Susie's hanging out over here. She's like, no, dude, I don't know what you're talking about. I drew 3 plus 4. Explain why Ben might interpret the picture this way. I don't really have an explanation because Ben is just being difficult. But maybe he's reading the picture from his left to his right, giving 4 plus 3. Where Susie's looking at it, actually I should do this. Oh, hold on. In red, Ben is reading from his left to his right, and he got 4 plus 3. Susie's reading from her left to her right, and she got 3 plus 4. Do they both get the same answer? Yes, they do. I don't know why we're talking about it, right? They both get the same answer. It doesn't matter, okay? I can add in any direction. Susie adds more to her picture. She says, now the picture represents 3 plus 4 plus 2. How might Ben interpret this picture? Explain your reasoning. I really don't have reasoning. Ben's just being silly. He's probably saying 2, I'm going to run out of colors, plus 4 plus 3. Ben's reading in this direction, and he reads 2 plus 4 plus 3. I think Ben's supposed to be red. We're going to switch colors. Susie's reading from this direction, and she's reading 3 plus 4 plus 2. Do I get the same answer both times? Yes. Yes, I do. Susie and Ben are struggling here. Susie then draws a picture, another picture of squares to represent the product 3 times 4. Ben moves to the end of the table and says, from my new seat, your picture looks like the product 4 times 3. What picture might Susie have drawn? Why would Ben see it differently from his viewpoint? Other than Ben just being difficult, we're going to say Susie's hanging out over here, and she sees 3 times 4. Ben's hanging out up here, and he sees 4 times 3. Okay, my squares are arranged in a grid just like we learned area. Susie made 3 rows of 4. Ben has 4 rows of 3. Do I still have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 squares? No matter if I start counting from this side or from this side, my area inside the the grid is constant. No matter if I'm sitting in Susie's seat or I'm sitting in Ben's seat, my area is constant. The amount of small little squares is completely solid, right? Well, draw a picture to represent the quantity 3 times 4 times 5. That could also represent the quantity 4 times 5 times 3 when seen from a different viewpoint. We're going to challenge my three-dimensional drawing. If I look at this one, let's try it in purple. 3 by 4. I'm going to do 3 by 4. I think I'll need more space. 3 by 4. So 3 by 4. This is going to be by 5. So I have 3 by 4 by 5. 1, 2, 3, 4, 5. I have to finish it. Sorry, you guys have to wait. Just watch me draw on lines like a master. Okay? So here I have 3 times 4, which is the front face. We can just say 3 by 4 is my, not what I wanted, sorry, is my front face. Right? And then times 5 is my depth. Okay, let's try it again. What if I did 4 times 5 times 3? So I need 4, let's see, 4 times 5. So it's going to be 4. This drawing may not be drawn to scale. By 5, so I have 4 by 5 for that front face, just like we did on the left. Oops, not the marker I wanted. Oh goodness, I did it again. 4 by 5 is the front face. And now I need to do a 3 as the depth, and I'm out of space. It's going to be 1, 2, 3, and then go down the side. So this is 3. That is my depth. Now I have the same number of cubes, the same number of pieces on both drawings, no matter if my front face is 3 by 4 or my front face is 4 by 5. Okay, they're exactly the same number of cubes. Its volume is still 3 by 4 is 12. Sorry, that was odd. 3 by 4 by 5. So 12 times 5 is, goodness, that I should know. And here I have my front face is 4 by 5, which is 20 times 3, which is also 60. Okay, volume is the same no matter what. We just learned our 4 of the properties of arithmetic. First of all, we have the commutative property of addition. That just means A plus B is the same as B plus A. The associative property of addition, which just means those letters associate with each other in a different way. I don't know, I think about associates, friends, coworkers. In the left side of the equal sign, A and B are closer than C. On the right side of the equal sign, B and C are closer than A, but no matter what, all three of them are friends no matter what. Okay, I can just group them in different groups. Then I have the commutative property of multiplication. Okay, either order, doesn't matter. Or the associative property of multiplication. I can group them in any way. They're different associatives, they're different friends, they're different coworkers. A and B are a little bit closer, but C is still there. B and C are a little closer, but A is still there. It just doesn't matter how you group them. Viewing the diagram below from two different perspectives illustrates that 3 plus 4 plus 2 equals 2 plus 4 plus 3. Is it true for all real numbers, x, y, and z, that x plus y plus z should equal z plus y plus x? Note, the direct application of the associative property of addition does state this. Okay? So, is it true? Let's look at a flow diagram. All right, what I've drawn here is a flow diagram. So we're just going to talk about how I get from this piece to up here, this piece. Which property have I used? The associative property of addition or the commutative property of addition? So to go from here to here, it looks like all the letters are in the exact same order. I've just grouped them in different ways. Grouping them is different associations, right? So I can say the associative property of addition. And if I look from here to here, okay, this grouping just moved to the back side and the Z came up front. So I've done different order here. So that would be my commutative property of addition, right? Okay, I can extend this diagram to do more things. So it looks like from here, I can even go a little further. What if I do z plus y plus x? What have I changed? Y plus, I said y plus x. Yeah, x plus y just flipped orders. So when I flip orders, I'm changing my commutative property. What if I come down here and do z plus x plus y? What have I changed? Everything's in the same order. Everything's in the same order. I've just grouped them in different ways. So that's different associations, or my associative property of addition. I could keep going. I could change this and change this until I'm blue in the face. But I'm going to stop. All right? All right, let's draw a flow diagram to prove that x, y, z equals z, y, x for all real numbers. So I'm just going to do a flow diagram. And first of all, I'm going to do this. And then down here, I'm going to go ahead and try this. Okay, what property did I use to go from here to here? XYZ is that order. I'm still XYZ. I've just grouped them in different ways. And when I group them, they are making different associations. From here to here, this is XYZ, this is Z, XY. So I flipped the order. That's my commutative property. Okay. All right, now let's fill some things in. So I'm going to use the abbreviations they've given for the properties of real numbers to complete the flow diagram. These are all of the symbols I'm going to use. So I'm really just seeing, like, between one thing to another, what changed. This is where I'm starting. So x plus 4, 5a, 2xy. Okay, so up here, what changed? It looks like 5a, 2x, and y have been moved to the beginning. 5a, 2x, and y. X plus 4 is the back. That's my commutative property. There's an addition sign in between, so I use the commutative property of addition. If I go from here to here, The only thing I can see that changed is this order right here. So that's also going to be the commutative property of addition. I can't fit it in that little circle. Sorry. All right, let's check the next one out. So let's go from here to here. What's changed? It looks like right here, this right here has changed. Okay, a different order, and it's the multiplication part. So I can say that is my commutative property of multiplication because it went in a different order and it's that multiplication. Now from here to here, beginning, okay, looks like right here something's changed. It looks like a different grouping. The parentheses have moved. That's a different association with multiplication. Okay, here to here, let's analyze it. 4 plus x plus 5, I've got 4 plus parentheses x plus 5. So it looks like the parentheses here, the parentheses moved down one and it grouped the total end. So that would be my different groupings is association of addition. And then from there to there, what's changed? Ooh, it looks like this whole group of things went to the front. So it's just in a different order. There we go. All right, one more. This one's a little easier. That last one was pretty difficult. So let's see what happens. A, B, C, D, looks like parentheses here, there, and none to the end. Looks like I just regrouped right here to here. So that would be my associative property. Then from here to there, I need an associative property. So, I'm not sure. I know I'm going to regroup, but how do I regroup? So here I just moved my parentheses down there, move my parentheses down there. I have to do something else to get to this. So I'm moving my parentheses once and then once again. So I know I have A plus B plus C plus D. This last one looks like that. So I'm definitely going to keep that A out and keep my B plus C here. But it looks like I need to move a parenthesis down here. Did I change anything? Yep, I took this parenthesis off and moved it like this for that one. Oops, I need that. Okay, erase that because that doesn't really count. Now let's make sure to go from here to there makes sense. Yep, because then I just go from here to there. That's my associative property. Okay, we don't want to show that though. So it looks like that's right. Okay, that was a little tricky. Okay, how to fill in the blank. That's actually it for today. You can go ahead and start your problem set. The assignment should be on your chart in your notebook or on the board. Cool, good job.